Hello and welcome. I'm Jamal Rahal, your moderator for this episode of IBM Tech Talk. Today, we'll be discussing how adding predictive analytics capabilities to your existing BI solutions can help you make better, more effective decisions. We'll talk about predictive analytics techniques that you can use to plan and forecast more accurately, and look at strategies for integrating predictive analytics into your BI workflows. We'll also walk you through some examples of using predictive analytics in BI to solve real-world business problems. Both of today's presenters will be available to answer questions during the Q&A session at the end of this webinar. And now, it's my pleasure to introduce today's first presenter, Jorge Garcia, Senior Analyst for Business Intelligence and Data Management at Technology Evaluation Centers. Welcome, Jorge.
Thanks, Jamal. Good morning, everyone. In today's session, I'll be speaking about expanding BI capabilities with the use of predictive analytics, a topic that is gaining popularity in the IT and the business intelligence space. I will be addressing it from two simple perspectives. One is their integration to expand the data analysis ecosystem, and two, by framing a specific example of use in forecasting and planning, a use case which some organizations are applying to take advantage of the use of predictive analytics. Let's do a quick review of today's session outline. We will start with a brief introduction to establish some of the principles of BI and predictive analytics, so we can see their basic differences and limits, as well as some of our findings about what users are looking for when evaluating BI solutions. This will help us to establish the principle by which we base the need for both to coexist within the same infrastructure, providing some thoughts and insights about its usage, and establishing how predictive analytics functions can enrich but not replace what BI solutions are able to achieve, and, as a consequence, expanding the potential of BI into a complete virtuous data analysis cycle for improving the decision-making process. Later, we will explain some of the basics of forecasting and planning as part of the predictive analysis discipline, a couple of examples and applications of them, and finally, of course, give some conclusions to our session by providing some final thoughts on how to get started and take advantage of the use of BI as the ideal starter for a predictive analytics strategy within an organization. Of course, all of this before a really interesting demo provided by Matt, which will let us witness predictive analytics at work. So, let's start. In today's business world, there is almost no denial about the importance of having business intelligence and analytics tools within the organization. But BI is not just about software tools. Business intelligence as a discipline comprises a set of software applications, techniques, and methods that enable decision makers and information workers to perform or benefit of the results of an effective analysis of data. The aim of these tools is to provide understanding, general or specific, about the status of an organization or a line of business, and to promote the improvement of the decision-making process. After some years of exercising the practice of BI in many industries and organizations, most of them recognize that a typical BI process involves some key functions, which include collecting the data coming from a wide number of sources, such as enterprise software solutions, ERPs, CRMs, etc., directly from relational databases, such as the Oracles, the DB2s, and others, or directly via Excel spreadsheets, text-based documents, and today, of course, even modern big data sources. Once collected, data is handled and treated to improve its quality, conform to certain rules for analysis purposes, and then stored within a repository, a data warehouse, or data mart. In its last stage, data is subject to various types of analysis, and finally, special tools are used to show the results using the best possible visualization method. It could be a report, a dashboard, a scorecard, and so on. Despite having shown limitations, in some cases BI has transformed itself into a process in continuous evolution. Even forced by a series of increasing demands, especially for effectiveness and timeliness, and the increasing need for data in real time, the inclusion of big data sources and others, this cycle has a well-defined set of virtues. But BI has also, more than ever, the need to incorporate new disciplines and technologies. And certainly, this is happening. Now, if BI solutions are applied at their full potential, they can bring many benefits to an organization. They can provide a virtuous data cycle that enables organizations to ensure successful data collection, increase its data quality and profiling. They can improve data availability, security, and reliability. And they can also provide us with accurate answers to how a company is doing at present. Of course, they can provide better decision alignment for the organization by being a reliable and single source of information. But yet again, to gain competitive advantage, modern organizations are transitioning their BI platforms from being able to react effectively and timely to be proactive. And for many organizations, being proactive means to look into the past and present and be able to predict the future. BI applications have the power to handle past and present information, analyze it, and provide an understanding of what's happening with the business, so users will be able to act upon them. The value of BI to provide a status update, how an organization is doing now, has not changed. BI continues to deliver the necessary information for decision makers. But new business requirements are demanding an expansion of the original BI infrastructure. Organizations have new requirements for use of their data. They need to anticipate, they need to forecast, predict, and respond proactively. This is when predictive analytics tools come into play. The discipline of predictive analysis, or the use of predictive analytics, mean implementing and using several analytical and statistical techniques to the data and develop what is called a prediction model. These models are mathematical functions that map data into business problems and reflect it in the trend or state of a target variable, generating a prediction or likelihood of an event to occur. As predictive analytics are part of the data mining discipline, data mining components are common within predictive analytics applications. Data mining is the process of analyzing data to discover hidden trends, patterns, and relationships within it, and is often the first step in the complete predictive analysis process. Predictions can be set across many business areas and across many types of organizations. They can be used in product supply and demand versus inventory levels, in customer lifetime value and likely churn rate, or they can detect customer shopping and consumption behavior. Differentiating themselves from other BI solutions, these disciplines, predictive analytics and data mining, jointly enable two main uses for historical data, which is predicting trends or likelihood of future events. What is the level of risk for a loan? Will a customer churn, and if it does, when? Or discovering patterns in data. What traits make a new client credit-worthy? Does the data reveal a pattern of side effects of a drug on new patients that researchers cannot see? All these are common cases and applications of predictive analysis. Now, before expanding more into predictive analytics, allow me to take a minute and share with you some interesting insights we have found in our research in regards to the importance of predictive analytics among BI users. From data collected during 2012, among ERP users using our diverse evaluation sets and gathering a sample list of top functionality features, we perceive that when evaluating ERP software options, users are looking for two main functional features. These stand out in second and 11th position respectively. One is BI and performance management, and the other is analytics. We can see that ERP users consider BI and performance management applications to be top priorities for the organization, These two main capabilities are important for improving data analysis and management and for the decision-making process. It is possible also to see that these organizations are now mature enough to realize how important it is to count with the abilities for monitoring and analyzing the business. On the other hand, organizations are also increasing the search for specific analytics capabilities, which include, of course, predictive analysis and specific line of business and industry vertical analytics. As we can see on the next slide, if we dig a bit deeper within types of business intelligence capabilities on the rise, it is possible to see that data mining is a top priority, and predictive analytics is scaling positions at number 7. Among BI users and organizations, having functionality for predicting and anticipating is increasingly important, especially in those organizations already using business intelligence tools. Those looking also to expand their data analysis capabilities and to increase operational efficiency and perform with better enterprise alignment. Putting all this into perspective, we can see that business intelligence deployments have been evolving over time. Taking a general approach, we have witnessed how a vast number of organizations have already passed the phase of working directly with raw data and using simple office tools to track the numbers, to use reporting and analysis tools which have helped enormously in the process of consolidating results. This also enabling better diagnosis of the business. But also, an increasing number of, let's call them transitional organizations, are on the hunt for more complex analysis technologies. We have detected in tech that some organizations are now in this transitional phase and have the need to expand their core business intelligence capabilities with abilities for anticipating, especially those organizations transitioning from the medium to large market. So, as BI applications evolve, the emergence of preset analytics applications are enabling them to go further with the study of historical data and to provide, based on the same historical data, ways to detect trends, to detect patterns, and most important in our use case, forecast results for business improvement and efficient planning. We see this clear trend as organizations also focus more and more on the daily operation, what we call operational or real-time business. So anticipating, forecasting, to achieve better performance, to achieve efficiency and capacity of reaction to the unexpected is increasingly crucial. Now that we have established the basis of what BI and predictive analytics are, and with some details about what users are looking for within a BI solution, let's continue describing more details of the why and how to expand BI adding predictive analytics capabilities. Even though I have heard many times about predictive analytics being the new BI, I strongly believe this is not about a substitution but an inclusion, where both disciplines have their own and very well-defined space within an analytics ecosystem. While BI continues to deliver crucial information about past and present, predictive analytics expands BI's reach to deliver views on future scenarios, likelihood of events to take place, behaviors, etc. A BI platform coupled with predictive analytics capabilities can expand the analytical reach of information workers to improve and widen their decision-making abilities. As the data is derived from all the organization's phases, past, present, and future, BI existing infrastructures can talk about the present, while predictive analytics can, as we mentioned previously, anticipate trends or likelihood of future events, or can mine the data, which means discovering patterns that we need to know. This increasingly closes the gaps between all levels of business analysis and provides a multiple set of perspectives at all levels of the organization: high direction, medium management, and operations. It also provides different data process perspectives to operations, to medium strategy, but also very useful for long-term planning. So, the predictive analytics stack has its place into the complete business software stack, especially the one that pertains to operation efficiency, business monitoring and performance, as well as a short and long-term planning. This helps collaborating into the alignment of all segments of the organization. While BI applications have a great impact on both operational and strategic levels of an organization, predictive analytics tends to directly affect and enhance operational decision-making by proactively identifying risks and opportunities, thus promoting direct action in an organization's operation. This, at the same time, enables anticipation and taking action based on it, which is why predictive analytics can make a perfect fit for its use in forecasting and planning. Let's take a look into our main example. Forecasting is the process of making statements about events whose actual outcomes have not yet been observed. So, how forecasting can be used in planning? Well, it is used, for example, to forecast demand for products and services, or to check the availability need for human resources. It can also forecast daily inventory and material requirements. As forecasting planning can have an effect on the decision we make today, addressing risk and uncertainty are central to forecasting and prediction. It's generally considered a good practice to indicate the degree of uncertainty attached to forecasts. Also, considering that the data must be up to date in order for the forecast to be as accurate as possible. In practice, we can do forecasting in two main ways, as we do with many other disciplines, applying a qualitative method or a quantitative one. Qualitative forecasting techniques are subjective, based on the opinion and judgments of experts or authorized voices. We can use judgments, causal factors, surveys, or even research and analogies. On the contrary, quantitative forecasting models are used to forecast future data as a function of past data and applying mostly mathematical techniques. This is the one we are more interested in because of the use of predictive analytics functions. Qualitative methods are commonly used when past data are not available or not reliable, and usually apply to for intermediate or long-range decisions. Quantitative methods are more suitable when historical data are available or reliable. These methods are usually applied for short or intermediate range decisions. Why? Because in nature, forecasts are rarely perfect, are more accurate for group data than for individual items, and are more accurate for shorter than longer time periods. From our previous description, quantitative methods are the ones we are interested in, because they are the ones taking advantage of existing predictive analytics features. As such, they have many different approaches available, but some of the two most important are time series models and causal models. Time series models assume that information needed to generate a forecast is always contained into a time series of data. On the other hand, causal models, or associative models as we call them, can explore the causes and effect relations and come up with a forecast. So, based on these two main approaches, we can apply specific models depending on the complexity of the problem and the precision we want to achieve. Time series models can be as simple as an AE problem or as complex as a moving average, or we can apply causal models or associative models by applying a linear regression or a multiple regression methodology. These are, to mention just a few samples of many approaches available, but probably some of the most popular fall in the category of simulation. Simulation is the imitation of a real-world process or system over time. The act of simulating something requires first a model to be developed. This model represents the key features or behaviors of the selected or real system. Now, there are two popular simulation methods. One is the Monte Carlo one, which consists of building a mathematical model of possible results by replacing a range of values. We use mostly probability distributions for this. On the other hand, we have what we call what-if scenarios, which consist of studying how uncertainty on the output of a mathematical model or system will vary according to different inputs and applying certain conditions of uncertainty on the system. One of the greatest advantages of predictive and specific purpose analytics is the possibility to apply these and more approaches on top of BI infrastructures that already had the data, or with fresh new data taken directly from a given source. Moreover, by using these applications, information workers or data scientists, as they are being called today, can provide organizations with repeatable and automatically executed processes that 1. Save time, and 2. Save resources and of course money. So, the planning and forecasting process is a continuous cycle. The input provided to the forecast method will generate outputs that, interpreted by information workers or decision makers, and in combination with other factors, will serve as a feedback to prepare the input for a more accurate forecast. Forecasts needs to be rolling processes. They need to be adaptable and evolving and within an evolving cycle, but also always subject for improvement. So, forecasts can impact not only users' functions, but all other operation decisions, such as preparing for a drop of sales, preparing for new businesses, or determining upcoming warehouse space requirements. So, the primary advantages of forecasting are not just predict the future or learning from the past, but can help us keep looking ahead and, of course, remain competitive. These are just part of the benefits of having a good forecasting and planning strategy in place. But again, taking into account that, as we mentioned earlier, forecasts are rarely perfect and they tend to be more accurate for shorter than longer term periods of time. So we know that it's not possible to accurately forecast the future. So we need to come up with a plan and highlight the need for, first, identify suitable metrics for testing solutions. We need also to have an accurate management of uncertainty to ensure, 1, timeliness and reliability of information, and also to ensure alignment across the organization. As a brief reference, let me show you a couple of examples of how organizations are currently using successful deployments of analytics to extend their BI strategies for planning and forecasting. First, we have the case of a deployment of a planning and forecasting solution on top of a BI deployment, which enable an organization in the life sciences industry to use their already effective data analysis infrastructure and expand its potential. This led the way for the company to important improvements in many of their planning and forecasting efforts for clinical trials. Some of the immediate benefits of this were enabling rapid deployment, an iterative prototyping, and of course an increasing cost efficiency. These are just part of the immediate benefits. This enabled them to achieve more than 30% in time and cost saving for the forecast and planning development, and prove this by reducing risk and uncertainty to very low levels of less than 5%. So before concluding this session, let's say that identifying the specific need for undertaking a predictive analytics project is always key to ensure that the organization will be successfully deploying a predictive analytics project. This is very important if we want to obtain a quick return of investment. Finally, and to conclude with my presentation, A successful approach to adopting predictive analytics within an organization needs to incorporate or take into account four main points. One, we need to have a full understanding of the business need to create the proper scope for the predictive analytics deployment. Second, we need to appreciate the data in its preparation. We need to take into account the amount of data and the quality of that data in order to achieve the best result possible. Third, we need to use the right predictive modeling technique in order to get the best result. And four, we need to have a proper evaluation of our predictive analytics solution in order to do the best possible deployment. We also need to observe some basic principles. One is we need to incorporate the predictive analytics strategy into the organization's data infrastructure to ensure that we are using the right data at the right place. Also, whenever possible, we need to embed the predictive functionality within the pre-existing BI capabilities that we have on hand. So we need to make sure that BI and predictive analytics work together for the same result. And third, we need to ensure that we integrate the predictive analytics functionality into the complete business software infrastructure to enable a better business adoption. With this, I conclude my presentation and I will pass control again over to Jamal. Thank you.
Thanks, Jorge. And now, I'd like to turn the floor over to today's second speaker. It's my pleasure to introduce Matt Denham. Matt is a technical marketing specialist at IBM, and he'll be demonstrating how you can use BI and predictive analytics to solve some typical business problems.
Thank you, Jamal, and hello everyone. My name is Matt Denham, and I work in technical marketing for business analytics here at IBM. Today we're going to review how utilizing the capabilities of BI and predictive analytics can help solve typical business problems. So in this scenario, a fictitious telco company entitled MBI Telecom is struggling with high subscriber churn. So this is the problem we're going to try and solve. And with the flood of new mobile virtual network operators, things have gotten worse for MBI. Here I'll be playing the role of a business analyst tasked with understanding this problem and developing a plan to turn the situation around using a number of tools at my disposal. And these include various aspects of Cognos BI, such as Cognos Workspace and Cognos Insight, but I'll also be leveraging the capabilities of predictive analytics using SPSS Statistics and SPSS Modeler. So in Cognos Workspace, I can begin to compile the data that I'm going to use to perform my analysis. And Cognos Workspace allows users to pull data from different data sources onto a single dashboard. This data may exist anywhere within my BI infrastructure, so I can use the navigation pane on the right to traverse public folders to locate the report objects that I wish to include in my analysis. I'll be using my corporate data, which includes relevant information on the number of canceled or churned subscribers, as well as information on customer segmentation and revenue renewal numbers or figures. Once I've located my objects, I just need to drag them onto the dashboard. And after having done so and examining the results, I can see that revenue targets are being missed and deactivations or churn is on the rise. Another feature of Cognos Workspace is the visualization coach, which recommends the appropriate chart type by examining the underlying metadata. Here, perhaps customer segmentation might be better represented by a bar graph. So in order to curb this trend of increasing deactivations, I'll want to do a forecast of what this trend could look like if I don't make any changes. In order to understand the long-term implications of what effect these trends will have on my business, I'd like to create a predicted forecast of the next 12 months churn numbers based on known historical data. What would the result to the business be if no corrective action were taken? And how many more deactivations should we expect to have a year from now? To do so, I can use the capabilities found in SPSS Statistics by opening an existing data source, which contains information on the number of churning customers as compared with the total customer count over the last few years. In the tool, I just need to click Analyze, then Forecasting. Then I'll create a new model using the fields from my data source as the appropriate variables. This will provide statistics with enough data upon which to create a predicted forecast. When selecting the Statistics tab, I'll want to check the Display Forecast checkbox before moving on to the Output Filter tab and select the single best goodness to fit model. At which point I'll move over to the Save tab where I can pick and choose which options I want to have output into the resulting forecast. In this case, choosing predicted values. And this is where the magic of the model is done. Finally, I'll move on to the Options tab, and I'll specify that I want to see a forecast for the full 12 months of 2013 before confirming my choices. Now I can scroll down in the forecast to see the results, and the resulting graph is clearly here quite disconcerting in that there is no reason to suspect that the trend of deactivations will cease. In fact, the organization will be in a much worse position by the end of the year, and that means we need to act now to try and lower the number of churning customers. I'd like next to understand why my customers are churning, and ideally which customers specifically are most likely to churn so that I can take the appropriate corrective action. To help me make the required decisions and take this corrective action, I first have to understand why our customers are churning. I can create a statistical model to help me discover any correlation between churn and an unknown cause. Once again, based on historical data that I have stored locally in a spreadsheet, but I could also use data that our company stores in our data warehouse as well. SPSS Modeler is a data mining client which allows me to build predictive models quickly and intuitively without any type of programming skills, all just using a drag and drop interface. So I just need to create a stream for the model, which can be thought of as a logical workflow. And then I just need to create a reference for my spreadsheet using the appropriate node in the stream. I can preview the spreadsheet to show how it would appear in the model. In this case, my data contains information on each of our customers, including their ID, segment, the number of dropped calls they've experienced, but also some demographic data as well, like age, gender, estimated income, etc. All of this information will be relevant in understanding why my customers are deactivating. The next thing that I'll want to do is categorize these fields to determine how they'll play a role in creating the model. For example, the customer ID field, which should be categorized as an ID, and the churn field, which is a flag which measures whether or not a customer is active or has canceled, will be the target of my predictive model, since I want to know who is statistically likely to cancel and why. Since the rest of the fields are also relevant, I do want to include them as inputs in the model as well. The next thing that I'll want to do is select the Modeling tab and choose which algorithm I want to use. To help with the selection, Modeler has a number of built-in automatic nodes which select the top 3 algorithms. That's the auto classifier, and that can do the work for you if you aren't sure which algorithm to choose. Here I'll choose a C5 algorithm, which automatically detects that churn is the target field, and then I'll execute the stream. The resulting golden nugget shows me which fields are statistically significant with customers who have churned or deactivated. By reviewing the resulting bar chart, I can see that the number of dropped calls plays a significant role in a customer's decision to cancel their service. This certainly makes sense. If someone has experienced poor network quality, then it stands to reason that they'd want to look for a better alternative. I can also output these results to a table so that I can see the underlying data related to churn. Here, a number of fields have been generated by the model, which show whether a customer is likely to churn and the numeric probability or likelihood of that occurring. This will allow us to target those customers who are in the VIP market segment who are most likely to deactivate their accounts. It will also allow me to update my expenditures plan based on the information we've discovered about the role that network quality has played in predicting customer churn. I'd now like to add the forecast and predictor information back into my enterprise dashboard so that I can share and distribute the results with a wider audience of consumers. I can do so by creating a new tab and once again locating the statistics and modeler results which have since been published to the BI portal, and I can again use the drag and drop functionality to include it in the dashboard. So on this single pane, we're able to compare planned versus predicted churn for the next 12 months and also see why customers are churning, and maybe most importantly, which customers have a high likelihood to churn. All of this will help me take the corrective actions to stop deactivations. By clicking the Do More button, I can launch Cognos Workspace Advanced, which allows me to have even more control over how I'm viewing the results in my dashboard. I can then use conditional highlighting to focus on those customers which are predicted to churn, so that I can target these customers specifically and perhaps proactively reach out to them with an offer to help keep their account active. When I'm satisfied with the results, I'll click the Done button to return to Cognos Workspace. With the new knowledge that I've discovered that the leading cause of customer churn is related to dropped calls or network quality, I can begin to adjust my plan accordingly. To do so, I can launch the Cognos Insight Connected TM1 client from directly within my dashboard. My goal is to perform some quick what-if analysis to understand what the impact would be on capital cost expenditures if more maintenance is performed on the faulting cell towers that are likely causing call disruptions for my customers. The net result of these expenditures should decrease the number of dropped calls that are being experienced, and as a result, I'm hoping that churn should decrease accordingly. Originally planned or targeted deactivation quotas are budgeted to be about 10% below the forecasted churn results. However, I believe that by improving the cell tower infrastructure, we should see or expect a decrease of planned churn by an additional 5% per month. By committing these changes to the plan, I can return to my dashboard and refresh the report object to see that results are updated appropriately. And now I can begin creating a campaign to target those specific customers who are predicted to deactivate. Throughout the course of this demo, we've seen how to leverage the capabilities of Cognos BI to analyze the current state of our business, only to realize that there were areas of concern where we needed to focus our attention. We then performed some forecasting using SPSS statistics to understand the impact to our business if we chose to take no corrective action. At this point, we used the predictive capabilities of SPSS Modeler to help us understand key areas of concern for the business, which essentially gave us the why and the what we needed to help make the appropriate decisions. Finally, we used Cognos Planning to do some what-if analysis and take the corrective action in terms of our expenditure plan. We then finished by showcasing how all of this data can be shared and distributed at an organizational level using the Cognos BI portal, so that the appropriate resources have all of the information that they need to help them make easier and more informed decisions. Thanks, and back over to you, Jamal.
Thanks, Matt. At this time, our presenters will take a few questions from the audience. If you have a question that isn't answered here today, you can follow up with either of our presenters using the contact information you see on your screen.
Jorge, first question is for you. Our audience would like to know what are the key things that a company would need to look for in a predictive analytics solution?
Well, there are many things that a company would need to look for in a predictive analytics solution. One is, of course, the number of models or approaches that a predictive solution can handle. And of course, ease of use, that's a second one. And third one, and most important, the ability to integrate with the existing infrastructure. So I think that those three main things are important.
Thanks, Jorge. Matt, next question is for you. Our audience is wondering if you could expand a little bit on IBM's strategy for using predictive analytics.
Yeah, for sure. So I'm guessing a bunch of people have probably seen, Watson on Jeopardy. So that's kind of the direction that they're looking to go, is integrating predictive analytics kind of within the whole smarter planet idea, where we have full integration with business analytics, and we can help solve problems that way.
All right, thanks. Matt, I have another question here for you. What is a good approach for deploying a predictive analytics solution?
I guess you'd have to look at your requirements at the time, like you'd have to have a good sense of understanding what you're trying to solve, what questions you're looking to get answered before you can really get started, and then what you have in front of you as well, what do you have access to, and then just start building out your solution that way.
Thanks, Matt. Jorge, this one's for you. Do you think it's fair to say that a BI solution isn't a complete BI solution without predictive analytics functionality?
Well, not necessarily. I think, like Matt mentioned in a question before, it depends on the need that you have. But I think it's increasingly that will be the situation, and I think that many modern BI solutions will be incorporating predictive as part of their tool set. But again, it depends on many requirements that you have. If you have a specific use case for the use of predictive analytics, that will make that will serve. But eventually, I guess that in the near future, predictive analytics must or should be a given of any BI solution.
Thanks, Jorge. Another one here for you, Matt. One of our audience members would like to know where model assumptions are made explicit and tested.
Oh, that's a good question. You just have to go through a test data set, essentially, using Modeler, and there are configuration options for that.
All right, Jorge, this one's for you. You talked about solutions that use quantitative methods and those that use qualitative. Can you give us some examples of solutions that use each?
Yes, sure. Well, basically, I mentioned qualitative methods and quantitative to just emphasize the use of quantitative methods that use mathematical models. And this is building the case of predictive analytic solutions. We mentioned a couple of examples of using quantitative methods, such as detecting the risk of a fraud risk. Fraud detection is part of that, using mathematical models, etc. Of course, forecasting and planning is based on quantitative methods. But many times we also use qualitative methods specifically to do long-term planning, strategy planning, and we use a combination of it could be a mathematical model, but we use a combination of data gathered from different sources, and again, having also a very subjective component such as a survey and taking into account important opinions from recognized voiced or authorized voices, as we know. If you're doing perhaps a yearly plan from the advisory board in a company, then you might take the advice of 2 or 3 very experienced business people that could give you some advice on what direction to take. We can also apply some methodologies such as the Delphi and others to complement that part, but we use a combination of subjective and objective methodologies. That would be a good example, which is having a board that is asking for a long-term plan, not yearly, maybe 2-3 years ahead, and they take an opinion from different people, authorized people in the business world. That would be a very common case.
Great. Thanks, Jorge. Matt, this next one's for you. Can you talk a little bit about how BI solutions improve information security?
Yeah, for sure. So if you're looking at assigning, user-based security, you do that so that you ensure that only specific people have access to the appropriate data that they should be able to see. I think of sensitive data, concerns about sensitive data like HR data, for example. You'd want to take the steps necessary so that only those people can see the information that's relevant to them. And then on the BI side, it would also facilitate sort of the ability to share that information with, again, the same individual that has the appropriate data access.
Thanks, Matt.
That brings us to the end of our time today. I'd like to thank our presenters, Jorge Garcia and Matt Denham, for being with us, and thanks, of course, to all of you in the audience for joining us. That concludes today's webinar.